Student, today we will learn the chapter Binomial Theorem any index. In the previous video I have described about the binomial theorem for positive index, right? So if you have viewing these lectures then you can do these lectures. Okay, so for any index the meaning of that is that we start with x plus a to the power n. In the expansion of this, nc0 x e power n minus x e power n a to the power 0 plus nc1 x to the power n minus 1 a to the power 1 plus dash 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 ncn x to the power n minus n a to the power n. This is the binomial theorem for positive index. You have already discussed in the previous video. So now I am going to tell you first slightly for this and then for any index. Okay, we start from the main first point that using this we want to be explain this 1 plus x to the power n. Then we get nc0 plus nc1x plus nc2x square and so on ncn x to the power n. So first point is this in this expansion we want to find the coefficient value which is the maximum. Okay, to find coefficient of maximum value. So we notice that in this general term in tr plus 1 coefficient will be ncr. Here you can see in the first term it is 0, in the second term it is nc1 and third term it is nc2, so ncr. Now if now note down, if n is even then maximum value of coefficient if r equal to n by 2. Now if n equal to odd, then maximum value of coefficient if r equal to half n minus 1 or half n plus 1, both are equal. Okay, both are equal. Now second point I want to describe you that in expansion of one plus x to the power n, if we want to find the maximum term in expansion of 1 plus x to the power n, if we want to find the term which will be maximum in value. Okay, so what we have to do, we have to do first taking the tr plus 1 upon tr. When we find this, we will get the this ratio, that is n minus r plus 1 upon r and x upon 1. X is here second term and 1 is here first term. Using this ratio, if we write this way, n minus r plus 1 upon r and greater than or equal or less than 1. Okay, now we find the value of r. We will get this one, n plus 1 into x upon x plus 1. Okay, if we are taking one here a plus b to the power n, then x upon 1 is equal to b upon a. Okay, and b should be positive. We should not take the value of b as negative. Okay, then we write n plus 1 upon b upon a plus 1 b upon a. This b should be taken in positive. Okay, now if we find the value of r, there are two conditions. Condition number 1, if r equal to, let any p integer, if r equal to p plus fraction integer plus fraction, example p equal to 5 and here r equal to 5 plus 1 by 2, 5.5. this is the example. Then you can say in this case, there will be two term, in maximum value, that is tp and tp plus 1. In value they are equal. Okay, and here you can say one term will be maximum, that is tp plus 1. Okay, so this you have to learn. Okay, now student, so our topic is that if n is any index, then what we do. Now if n is any index, means in expansion of in expansion of 1 plus x to the power n, if n is any index positive, negative, fraction, n may be positive, negative, fraction. Okay, then how you can describe it? The formula is same, and also x less than 1. These are two conditions. Then the expansion, in the expansion we cannot write the value of ncr, since if r is negative or n is negative or fraction, we cannot use it. Okay, so now student, we can say the expansion will be this way: 1 plus n x. Now this you can see the value of nc0 equal to 1, nc1 equal to n, okay, and plus n minus 1 upon factorial 2 x square, nc2 equal to n minus 1 upon factorial 2, but you cannot write here nc0, nc1, nc2 and so on, and this expansion will be up to infinite. Okay student, so the general term will be here tr plus 1 is equal to n minus 1, n minus 2 dash 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 n minus r minus 1 upon factorial r x to the power r. You can see here, if it is fifth term, then it is 4, then it is 3. Okay, if it is 4, then there are 4 factor here and also power 4. If it is fifth term, this will be 4 and this will be 4 factor. So this you should have understand for any index, right? So using this we can learn the following series: 1 minus x to the power minus 1. Using this formula we will get, when this series we will find here 1 plus x square plus x cube plus dash dash dash. Okay, so student, you have to learn this. Okay, now if we get here 1 minus x to the power minus 2, what we get here? 1 plus 2x plus 3x square plus 4x cube plus dash dash dash. So this way you have to learn better. If it is minus 3, now you can say 1 plus 3x plus 6x square plus 10x cube plus dash dash dash. Now you can see here 1 2 3 4 in is AP, and so if you want to find the sum of this, you have to compare these expansions, right? So if both are negative, this one and this one negative, you can see here all terms are positive. Okay, all terms will be positive, then you should be understand these are negative. So now if you want to find some more about this, now to find the maximum term of this what we have learned, so we go to the equations. We will do equations to find 5 plus 7x minus 9 to the power 4 in expansion of this. In expansion of this to find maximum value term. Okay student, now we will use this formula n minus r plus 1 upon r into in the expansion of a plus b upon n, b upon a, b should be in positive, equal to 1. Okay, but for negative value of n, we use this formula minus n plus r minus 1 upon r, b upon a equal to 1, and we left this minus sign. So when we use this formula, minus 9 by 4 plus r minus 1 upon r, and that is in our question, that is 7 upon 5, and x is value is given. What is the value of x is given, and we can that is given. Our x value is 5 by 8 equal to 1, so we can find the value of here 9 by taking LCM here, we can get 9 plus 4r minus 4 equal to 8 upon 7, and we can get here 5 plus 4r equal to 32r upon 7, and 35 plus 12r for 28r equal to 32r, so we get 35 equal to 4r. So now we get r equal to 35 upon 4 is 8 plus 3 by 4. So now it is integer plus fraction, hence we can say in our formula the T8 plus 1 term is maximum value term, okay, equal to T9th term. So student, this way we can find the maximum value term if n is negative. So taking the common minus, we can left the minus first, then you can this value. Now one more questions I want to be describe you. This is very important question. 1 plus x to the power 2 upon 1 minus x to the power 4. In expansion of this, find coefficient of x to the power 8. So first we write this way, okay, and open this, and you have to expand only the second term 1 minus x to the power minus n only. This you have to expand it, and first find the coefficient of x to the power 8 in this term, okay. So general term will be in this term. What will be the general term? That is the minus 4 minus 4 minus 1 dash 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 minus 4 minus let it is nth term, n plus 1th term, then it is n plus 1 upon factorial n, and x to the power n. So taking the minus common, what you get here, minus 1 to the power n, and here is 4 5 6, that is n plus 3 upon factorial n. Okay, so and this is the coefficient of x to the power n. First you have to multiply it here 1 2 3 and get the factor n plus 3, and then you can write here minus 1 to the power n upon 1 2 3 factorial n 1 2 3 4 5 6 n plus 3. Okay, now you can write the last this term and you can find here minus 1 to the power n, and that will be the term var n plus 1 n plus 2 n plus 3. Factorial n term will be cancelled and 1 2 3 will be left here. Now this way you can find the coefficient of x to the power n. Okay student, and then find the coefficient of x to the power required coefficient of x to the power 8, and you can see here now the coefficient of x to the power 8 you want to find here. So 1 into coefficient of x to the power 8 plus 2 into coefficient of x to the power 7, since x power 1 is here, and 1 into coefficient of x to the power 6. We have to find this. Okay, so coefficient of x to the power 8, 7 and 6, you have to find it. So now coefficient of x to the power 8, put n equal to 8, and after calculating it 8 plus 1 8 plus 2 8 plus 3, what we get here you can get the value of नजर नहीं आता. Coefficient of x to the power 8 and power 7 and power 6 you have to find out. So let okay, this you have to calculate yourself. If I put here, put n equal to 8 and then coefficient of x to the power 7, put n equal to 7, let we get here a, we get here b. You calculate yourself. Coefficient of x to the power 6, put n equal to 6, let it is getting c. So what will be your answer? Answer will be 1 c, and you can see here 1 coefficient of x to the power 8, here coefficient of x to the power 7, here coefficient of x to the power 6. Okay, so what will be your answer? 1a plus 2b plus 1c, and this is calculation. After that you will get the answer 1a plus 2b plus 1c. Okay student, now you can calculate yourself. This way, this process you will be used in other equations. Now we are going to be explaining this way. Find s equal to 1 plus 3 by 4 plus 3 into 5 upon 4 into 8 plus 3 into 5 into 7 upon 4 into 8 into 12 plus dash 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 up to infinite. This is a very important questions. Okay, so student, in this question let s equal to 1 plus x to the power n, where x less than 1. So we can get LHS equal to 1 plus x to the power n, and RHS is equal to 1 plus nx plus n minus 1 upon factorial to x square dash dash dash. Now comparing this nx and this one, what we find here? We find here nx equal to 3 by 4 and n minus 1 upon factorial to x square equal to 3 into 5 upon 4 into 8. Now solving these two equations, we can get the value of x and n. So we can get the solutions. Okay, so let us start to solve these questions. Now put the value of x equal to 3 by 4 upon n here. So we get n minus 1 upon 2 into 1 into 3 by 4 n into 3 by 4 n. Okay, x square, x equal to 3 by 4 n. So now you can solve these two very well. Okay, so cut this n, and now you can solve this yourself, so that's no problem. Or should I solve it? Okay, let's solve it. So 3 by 4 is cut with 3 by 4. Okay, so we get n minus 1 equal to 5 upon 8 into this 4, this cancel out, and this 4 upon 3, what we left here, into 2. So we get here 2, 5 by 3. So n minus 1, n equal to 5 by 3 plus 1, and so we get value of n is 8 by 3. What we left here, n minus 1 upon factorial to 3 by 4 n, 3 by 4 n. Okay, so what this is here we get n also, so write here n. Okay, so what we get here, 3n minus 3 equal to 5n, and minus 3 equal to 2n, n equal to minus 3 by 2. So this way we get the value of n minus 3 by 2. Now we can find the value of x, hence x equal to 3 by 4 minus 3 by 2. So we get here, that is minus 1 upon 2. Okay, hence s equal to 1 plus x to the power n for the value of x, and what is the value of x? That is minus 1 by 2, and n is minus 3 by 2. So your solution is 1 minus 1 by 2 to the power minus 3 by 2, and again you can solve this, isn't it? So taking LCM we can find out, and s is equal to the power 3 by 2, and to the power 3 by 2 can also write 2 root 2. So this is your required answer. Okay, right question. 2 cube is 8, so you can half is root 8 to root 2. This way you can find yourself. So student, I want to explain one more very important questions. In the expansion of 1 plus x cube power n, we get 1 plus nx plus n minus 1 upon factorial 2 x square and so on. If x is less than 1, so we can left the higher power of x. We can left the higher power of x. It means x square, x cube and so on, and we can say the expansion is only this. Okay, now using this we can find solve questions. If x is less than 1 and left the higher power of x, then find value of 4 plus x to the power 3 by 2 into 8 minus 6x to the power, let the power is 1 by 3 upon 1 plus x to the power 2 by 5. Okay, so before starting to this questions, we check here. If here is 1 plus x, then it may be expand, otherwise it not will be expand. Okay, 3 by 6 over 3 by 4. So we take the common first here, 4 to the power 3 by 2, 1 plus x upon 4 to the power 3 by 2. Okay, now take the common 8 here, 1, then 8 to the power 1 by 3 1 minus 6x upon 8 to the power 1 by 3. Then what we get here, 1 plus x to the power 2 by 5. So now it is okay. Now 4 to the power 3 by 2, first we have solved here. 2 square, 4, 2 cube means it is 8. Okay, 4 to the power 3 by 2 equal to 2 square to the power 3 by 2, 2 cancel, 2 cube is 8. So we get 8, and expansion of this we get 2 terms using the formula 3 by 2 into x by 4, 1 plus nx only. Okay, now it is 2 cube, 3 cancel, we can write 2 here, 2 cube to the power 1 by 3. Okay, it is 2. So now we can get 1 minus 6 by 8 into 1 by 3x, and upon we can write here 1 plus 2 by 5x. 1 plus nx, in expansion we are taking only 1 plus nx since higher power is negligible. So what we can write the next here, we can write here, and the previous calculation we have seen here, 8 into 2, first write 6, then write 1 plus 3 by 8x, and then write we can 1 plus we can see here 1 plus 3 by 8x, okay, 16, and here we to calculate here 6 by 8, so 3 2 2 1 by x by 4. Okay, so we can write 1 minus 1 by 4x, and upon we can write 1 by 2 by 5x. And now what is the next term? Next term we will multiply this. What we get here, 1 plus 3 by 8x by 1, and minus 1 by 4x minus 3 by 8x into 1 by 4x square. Now we leave it and we solve it only. So we can get 1 plus 2 by 5x, we get 16, 1 plus, now solving this we can taking the LCM 8, so we can 3 minus 4 minus 1 by 4x, so taking is minus 1 by 4x. Now taking this above, we can write 1 plus 2 by 5x to the power minus 1. Okay, now what we have done here, we have done the left this bracket and add this bracket, and then we write here and left this bracket. Okay, now again we can write here 16, 1 minus 1 by 4x and 1 minus 2 by 5x. Again we using the formula 1 plus nx, again we multiplied here. So what we get here, first check here what we get here. Taking the LCM 8, 6 minus 2, 4, 3 by 8 minus 1 by 4, 8, 3 minus 2, that is equal to 1 by 8. So we write here 1 by 8. Okay, so now after multiplying this, what we get? 1 minus 2 by 5x plus multiplied by 1 by 8x minus, we get here plus 1 by 8x into minus 2 by 5x. We left this, what we get? We conclude this one, so we write here only minus 2 by 5 plus 1 by 8. So minus 2 by 5 plus 1 by 8, we get here 16, 1 plus minus 2 by 5 plus 1 by 8x, left all this value. Now what we get? So we get here 1 minus 11 upon 40x. Okay student, so this is the final answer. So this way you can find so many values in other questions, and you can also take one more example. Solve 1 upon cube root 126 1 upon cube root of 126. So using this theorem, we can write this 126 to the power minus 1 by 3 and 125 plus 1 minus 1 by 3. Okay, now taking the 125 to common, minus 1 by 3, 1 plus 1 upon 125 minus 1 by 3. This can be written as 5 cube minus 1 by 3. Okay, so we can write 1 plus nx, and taking the higher power, left the higher power, so 5 to the power minus 1, and we can solve this one. 1 minus 1 upon okay, then after solving this, 1 by 5 and this, now you can solve further and you can get the value. Okay, so you can get the value near about 1.99 dash dash dash. So this way you can find your answer. So student, I am leaving this topic now, so go through your books and you can solve the questions. In the next lectures I will be try to give you the log and exponential series. Okay, thank you.